These are the notes for 7.1, inverse and direct variation. So if you want to use or get more information from the textbook itself, don't forget you can go to bigideas.com and view the textbook, and it has some more example problems at the beginning of 7.1. All right, so right here, after we go over everything, you can write in your own words the meaning of those vocabulary terms, inverse variation and constant of variation. But our core concepts that we're going to talk about are what we just said. Inverse variation, that is two variables, x and y, show inverse variation when they are related as follows. So if you have the equation y equals a over x, and a cannot be 0, and this a that it mentions is a constant, and it is the constant of variation. Okay, and y is said to vary inversely with x. So another way that you can write this, these can equal each other here. If I want to solve for that variable, to get a by itself, I'd have to multiply by x, so it'd end up with x times y. So if I have an equation either in this form with a constant divided by x equals y, or y equals a constant divided by x, or a constant equals x times y, then I know that it is a inverse variation because y varies inversely with x. Then if we go down to direct variation, two variables x and y show direct variation when they are related when y equals some variable times x, that a is still a constant of variation and y is said to vary directly with x. Okay, and again, we can rewrite this as solving for the variable. Well, to get a by itself, I have to divide by x, so I end up with y divided by x. Okay, they mean the same thing. So if I get an equation and it's solved for a variable, then I need to figure out, is y divided by x? Is y multiplied by x? So down below, whoa, we just jumped here. We want to tell whether x and y show direct variation, inverse variation, or neither. The easiest thing, I am going to stick with this neither just real quick and find a few of these very quickly. A few of these equations don't look anything like any of these four equations, or the way that those look. And a key there is, up here, there's no plus and minuses. Down here, I see some plus and minuses. If there is that, no matter what, this will be neither. Because this is solved for y, and it either needs to be a variable divided by x or a variable multiplied by x. But this is a variable added to x. So that can't be. This is going to be the same way because there is a plus. If I solve for y, it's actually going to have a negative x, so it's negative 2 minus x. Here's another minus. So I can just automatically say, I know those don't vary directly or inversely. Okay, but now let's go through. You can do one of two things. You can solve for the variable and see what it looks like. Or solve for y and see what it looks like, because up above we wrote down both equations. I personally like to solve for the variable, but that's just me. So if we look at number 1, to solve and get a variable to one side and x and y to the other, well, here's x and y, so I want to get rid of the 3, so I'm going to divide both sides by 3. So my constant here is 1/3, and it equals xy. So if I go back up to my inverse variation and direct variation, I have x times y in my answer, and 1/3 is my constant, and that is under inverse variation right here. Okay? Whoops, sorry. So I know that this is inverse variation. Okay. And again, if I want to solve for the constant in number 2, I need to multiply by x. So I'm going to get 5 equals x times y. Well, look, that looks like this. X times y. Constant on the left side. Okay, so this is also inverse variation. I'm just going to write inverse. Okay. Oops, zoom back out. Sorry about that. We had neither here and here and here. Okay. Okay, solving for the constant in number 5, because we already answered 3 and 4. Well, I want to get the constant by itself, so I'm going to divide by x. So I get 4/5 equals y over x. I don't care that that number is a fraction. A fraction is still a number. It is still my constant. I care what this right side with the x and y put together look like. Okay? So this is not x times y, so it cannot be inverse. But it is y divided by x. Therefore, it is direct variation. Now, if it was x divided by y, it would also be a neither. So just in case we come to that, I wanted to let you know. Okay, where are we at? Sorry. Direct. I had to write the answer. I was like, I knew I was missing something. Direct variation. I'm just going to write direct. Okay. Now, in this one, actually, we could end up with an x divided by y. That is, I said it would be neither, but I misspoke. I apologize. It would be direct as well because you can take the reciprocals of both sides and flip. So I can either divide by x, or I could multiply by 7 and then divide by y. Okay, it kind of gets messy. But I can leave the 7 over here. If I were to divide by x, x goes away, but it leaves me with 1. Okay, you always have something in the numerator. And then I said I divided by x, and I get y over x. Okay, that was the way to solve this with fewest steps there. So I know it's y over x, so that is direct. Okay. Now remember, if I get a constant over here, and it equals, so let me write over here, if I would have multiplied by 7 and divided by y, I would have had this. And it's like, oh, x divided by y, well, that's neither inverse or direct. But if I take the reciprocal of this side, and I take the reciprocal of that side, it's direct, okay? So these are the same. All right, so on number 8, let's get all the numbers to one side. So I want to get x and y by itself. So I'm going to divide by 6. So my constant is 0, because 0 divided by 6 is 0. And I get xy. Well, I can have that. Although it does say, okay, sorry I have to keep pausing this. My Siri keeps trying to take over. But I have that now the constant is 0, and up in the definition of inverse variation, it says A cannot be 0. So this one, even though it doesn't have the addition or subtraction in it, and it does have x and y together, it is still neither. Okay, this is the only instance you're going to get neither when there's not a plus or minus sign. All right, now on to number 9. I need to get rid of that 9 on this side, so x and y are by themselves. I'm going to multiply by 9, so I get y over x equals 9. Well, y over x is direct variation. All right. Then we are going to give you some charts here, and we want to know whether it shows direct variation, inverse variation, or neither. Okay, so if you remember here, let me zoom in to this one. Okay, this is inverse. We said inverse variation is x times y. And then this is direct when it's y divided by x. So we need to find these numbers. So to find all the inverse numbers, I'm going to take the x it gives me and the y it gives me and multiply them together. So I do that and I go all the way across. And then I look and I say, are any of those a constant number? Are any of them the same? These are not constant. Constant means it's the same number. Okay, so I know it's not, they do not, it does not show inverse variation. So let's try direct variation. I'm going to take y divided by x, so 4 divided by 2, and 16 divided by 4, and so forth, and do all of these 10 or 100 divided by 10. Okay, again, this is not constant. It's not the same number all the way across. So this is neither inverse variation or direct variation because it didn't have a constant x times y or y divided by x. So let's try on this one. Okay, so I'm going to do inverse first. I'm going to multiply x and y. So I get 5, 5, 5, 5, 5. Don't just assume you're always going to get 5 all the way across because like the first 3 are and you just say, okay, these other ones have to be and it's going to work. Double check. Make sure you have a calculator. Enter those in. Well, this is constant. Okay, and to be sure, I'm still going to check the direct by taking y divided by x. I get 5 and I get 1/5 and I get, 5 over 64 and I get 1 over 80 and I get 1 over 500. Definitely not constant. Okay, and x times y is inverse, so I know that is inverse variation shown in this chart. All right, the next one. Here we go. Oops. Okay, x times y all the way across. 1. I get 6.25. You can leave them as fractions. You can round them. Write them as decimals. The key here is even after doing like the first 2 or 3, and none of them are the same. It means I know I didn't make a little mistake there. But I know, because it's not constant, oops, I ran out of room there, that it's not inverse variation. So I go across the bottom and do y divided by x. They all are 0.25. So here we have this entire row is constant. So I know I have direct variation. All right, so that's how you're going to check those when you're given the just numbers for x and y. Now, if I get it the right size. Now, in these two problems, it says the variables x and y vary inversely. So it's telling you it's inverse variation. So we need to remember that inverse variation is y equals a over x. And then we are going to use these given values to write an equation relating x and y. And so our equation will look like this. That just means we need to use these two values and find a, because we don't want 3 variables in the equation. We only want x and y. But then, once we find a and write that equation, we want to find out when x is 2, what y is. So, 13 gives me an x and it gives me a y. So into that equation, I'm going to plug in the y equals a over x. All right. And then I need to solve for a. So you could have also remembered over here that a is x times y and not done it in this format. You could have done it as a is going to equal a -4 times 5. No matter what, you're going to get that a is 20. I just wanted to show you both ways. But when we write this as an equation relating x and y, this is the equation we're going to write. Okay, So the equation is going to be y equals a, which we just said, oops, and it was supposed to be a negative 20. It's a negative 4 there. So negative 20 divided by x. That was the first thing it asked us to do, was write the equation. So we did that. And now it says find y when x is 2. So I'm going to take this equation, and now I'm going to say, okay, well, x equals 2. So y is going to equal 20 divided by 2. And I did it again. It's a negative 20, guys. I'm sorry. This is negative. This is negative. So my answer here will be y equals negative 10. So the two answers I want were the equation itself, y equals negative 20 over x, and the answer when x is 2, which is y equals negative 10. Okay, so let's do it for number 14. Again, we want to find the constant first, so I use this equation just because it's easier. Oops, it's faster. So, and you take x times y. So I have that a is 6. And I'm going to plug that in to this top equation up here. Y equals what I said a is over x. So 6 over x. And then I plug in x equaling 2. So y is going to equal a 6 over 2. So y is going to equal 3. All right, so that is the notes for 7.1.